The ATTE's underbelly is the documented kill zone. The official Star Wars Databank puts it plainly. Tanksmasher rockets can pierce the ATTE's armor and destroy its complex propulsion mechanisms. 6 legs, hull low to the ground by design, acknowledged weak point in the belly sitting right between them. Work through the geometry. The ATTE stands 5.02 meters tall on 6 legs spaced wide and close to the surface. When a tanksmasher round destroys a leg assembly, the hull shifts. The belly drops. Whatever sits in that low-slung undercarriage, fuel systems, propulsion drivers, power routing, moves toward ground contact. In real armored vehicle engineering, that's cook-off risk. Heat from the initial strike propagates into adjacent fuel or energetic systems, and those systems ignite without needing a second hit. The databank entry acknowledges the low ground clearance made the ATTE susceptible to mines exploding beneath it. That's the same failure mode, stated differently. The belly vulnerability isn't accidental. It's built into the geometry of a vehicle explicitly designed to hug the ground for stability. The designers solved one problem and created another, and apparently never cross-referenced their own spec sheet. Landing at Point Rain, Season 2, Episode 5. Given the hull geometry, any fuel or propulsion systems adjacent to the primary impact zone would have no separation layer between them and the ground contact surface. And the official documentation that tanksmasher rounds destroy propulsion mechanisms confirms the impact zone is exactly there. The fix was standard before this galaxy existed. The M1 Abrams separates fuel tanks from crew with armored bulkheads and runs an automatic Halon fire suppression system. Fuel routes to the location least exposed to expected threats, separated from crew and propulsion by dedicated armor, not proximity. The ATTE needed the same. Armored fuel cells in the rear hull, away from the impact zone, with automatic suppression covering the propulsion bay. Not a complicated fix. A procurement line item that someone left off the checklist. Flaw 2 is harder to justify, because the solution was already in the vehicle. The ATTE's mass driver cannon, its primary weapon, the largest and most capable armament on the platform, is operated by a crew member sitting on top of the hull, not inside a protected turret with a hatch and armor. On top of the vehicle, in open air, over a battlefield. Wikipedia's technical documentation is direct. A final crew member had to sit behind the controls of the heavy cannon atop the ATTE, partially exposed to enemy fire. 1 sniper, 1 proximity blast, 1 piece of shrapnel from a near miss. Any of those neutralizes the ATTE's primary armament, without the enemy needing to breach the main armor at all. What makes this genuinely frustrating is the canonical evidence that remote operation was technically possible within the existing design. The mass driver is documented firing without a visible gunner on top in multiple cannon appearances, suggesting the remote capability existed. Someone in procurement decided not to make it standard configuration, and clone troopers paid for that decision on every battlefield from Geonosis to the Outer Rim. The M153 Common Remotely Operated Weapon Station, the CROWS, system adopted by real-world armored forces, eliminates this exact vulnerability. The operator stays inside armored protection. The weapon operates outside. The human is no longer the weakest point in the weapons system. The ATTE was one configuration decision away from this. The remote capability existed. The decision not to implement it as standard is the failure, not the design. Flaw 3 requires understanding what the ATTE got right before seeing where the design stopped. The ATTE features an articulated midsection that increases its mobility in the field. That flexibility is a real engineering achievement. It allows the vehicle to traverse terrain a rigid-body walker couldn't handle. The ATTE can scale vertical cliff faces, confirmed across multiple cannon appearances. The flexibility is the point. The articulated joint is also a stress concentration point. Any connection between 2 large, heavy, asymmetrically loaded masses creates a geometric discontinuity. a location where the structural cross-section changes, which is precisely where bending stress concentrates under dynamic loading. At the First Battle of Geonosis in 22 BBY, IG-227 Hailfire-class droid tanks engaged ATTEs across the battlefield. The character encyclopedia confirms a single Hailfire warhead was capable of destroying an ATTE. 30 guided missiles per vehicle, at ranges under a kilometer, following evasive trajectories. Under sufficient impact force, the articulated midsection was where the ATTE was most likely to fail structurally, because that's where the stress concentrates. The fix is progressive joint reinforcement with damage-tolerant design. Keep the flexible connection. Build redundant load paths around the joint, so failure is gradual rather than catastrophic, and reinforce the articulation with composite materials that absorb impact energy without catastrophic fracture. Known discipline. Available before Geonosis. Not implemented. 3 flaws. 3 real-world solutions. All 3 visible before the opening engagement of the Clone Wars. None implemented. The AT-AT is a different caliber of problem. Same categories of mistakes, repeated at 22.5 meters tall with 40 troops per vehicle. Star Wars Battlefront 2. EA/DICE. 2017. Hoth. Outpost Delta. Standing over 22 meters, armored to absorb nearly anything short of a proton torpedo, the AT-AT achieved its tactical objective at Hoth. General Veers led the Walker assault across the ice plains and destroyed the rebel base's main power generator. The machine worked. That matters. This isn't an argument that walkers are a bad idea. The AT-AT won the Battle of Hoth. It won despite 3 engineering failures that were visible from the first step onto the snow, and the rebel forces identified all 3 within the same engagement. Wikipedia's AT-AT article states it directly. The most vulnerable part of the Walker was its flexible neck, which was susceptible to lighter blaster barrages. The neck connects the command module, housing pilots, sensors, targeting systems, all Walker control functions, to the main armored body. That connection is a long lever arm under constant dynamic loading from the Walker's own stride, from main gun recoil, and from any lateral impact. Bending moment at a joint equals the applied force multiplied by the lever arm length. The longer the arm, the higher the stress at the connection point for any given force. The AT-AT's neck is proportionally long relative to the head it supports. That's not an aesthetic choice. It's a moment arm with cantilever beam properties, concentrating every external load into the same joint. The body armor absorbs blaster fire that the neck joint can't, because you can't fully armor a flexible joint without eliminating the flexibility that makes the head useful. That trade-off is real. The designers should have identified it and compensated in the joint design. They left it as the documented most vulnerable part of the entire vehicle. Luke Skywalker found the neck by improvisation after his snowspeeder was shot down. He didn't have access to engineering schematics. He had a lightsaber, a thermal detonator, and the observation that the belly and neck were softer than the front armor. That's the same analysis a structural engineer produces from cross-section drawings. When an improvising pilot identifies your critical vulnerability under fire before your design review team does, that's a procurement failure. The tow cable takedown is the most famous Walker kill in film history, and it deserves an actual mechanical explanation. At Hoth, Commander Skywalker ordered snowspeeders to deploy power harpoons with flexi-steel tow cables. Fusion disc harpoons attached to the Walker's structure. Pilots flew multiple orbiting passes, wrapping the cable around the legs. The Walker fell. Here's the mechanics. A 4-legged Walker maintains stability by keeping its center of gravity projected within the polygon formed by its 4 ground contact points. Canonical sources confirm the AT-AT had weak joints at the knees, with legs that weren't powerful enough to power through steel cable wrapped around them. Wrap a cable around one leg, apply increasing tension, and you generate torque at that knee joint. When the torque exceeds what the joint can resist, the leg arrests. One leg immobilized means the support polygon, the area within which the center of gravity must project for the walker to remain upright, collapses. With the walker in motion, the support polygon shifts continuously, and the center of gravity drifts outside it. The walker tips. At 22 meters tall, the center of gravity sits roughly 11 meters off the ground. That height amplifies every disturbing force applied at leg level. High center of gravity means even a small lateral force at the foot creates a large overturning moment at the tip-over axis. The ATTE's designers had already solved this. The databank states explicitly that the ATTE's low leg geometry dramatically increases stability compared to the AT-AT. Retired clone troopers encountering an AT-AT for the first time reportedly questioned how it could walk on 4 legs instead of 6. They understood the stability trade-off because they'd operated the more stable design. The AT-AT's height was chosen deliberately, terrain clearance over the mines that kept killing low-clearance ATTEs, and psychological effect against enemy forces. Both valid engineering reasons. Neither prevented widening the stance, reinforcing knee joints past the weak joint specification, or adding cable cutting mechanisms at the leg joints. Any one of those changes makes the tow cable tactic ineffective. None were implemented. The third AT-AT failure is command module placement. All pilots in the head. All control functions in the head. All sensors in the head. Canon is explicit. The pilots sit in the cockpit in the AT-AT's head, operating all walker functions from there. Any stability management system on a 22-meter walking machine routes through the head and neck connection. One has to exist, or the vehicle couldn't coordinate gait at all. A catastrophic neck failure doesn't merely damage the vehicle, it severs the control loop. The legs can't sequence without coordinated control signals. A walker becomes stationary debris from one strike to a single flexible joint. The ATST's 1998 Incredible Cross-Sections documents a powerful gyro stabilizer in the command cabin, a system of gyroscopes, hydraulics, and high-speed processors. That's for the ATST specifically. The AT-AT's gyro location isn't documented with the same explicit detail, but an architecture that concentrates primary control and stability systems in one elevated, neck-connected module with no distributed backup or redundant control pathway is a systemic vulnerability regardless of exactly where the gyro sits. Boston Dynamics addressed this with Atlas through distributed control architecture. A 2017 stability controller paper on the Atlas robot describes the core principle: an inverted pendulum model with continuous inertial corrections distributed through the chassis. Damage to any node degrades function rather than eliminating it. An AT-AT built this way keeps walking after the head takes a direct hit, impaired but operational. The current design stops the moment the neck fails, which is precisely the moment the neck is supposed to fail because that's what everyone shoots at. The ATST stands 9.04 meters tall. Body width, 4.5 meters. 2 legs. The 1998 Incredible Cross-Sections confirms it runs on a powerful gyro stabilizer in the command cabin, enabling remarkable agility across varied terrain. That gyro sits at the top of the structure, in the heaviest, most instrumented part of the vehicle. A bipedal vehicle's support polygon is a line between 2-foot contact points. The center of gravity sits well above the mid-height of a 9-meter machine whose heaviest component is the command cabin at the top. Vehicle resistance to tipping equals the distance from the center of gravity to the tip-over axis, multiplied by the vehicle's weight. Raise the center of gravity relative to foot spacing, and that resistance drops proportionally. The ATST's geometry, tall relative to its footprint, heavy at the top, minimizes tip-over resistance by design. Ewoks at Endor identified this without a stability calculation. Logs suspended on ropes, positioned at ankle height, generate maximum toppling moment from minimal mass. Striking at ankle height maximizes the lever arm between the impact point and the tip-over axis at the ground. The armor performed exactly as designed. In Star Wars Outlaws, point-blank blaster fire does essentially nothing to an AT-ST's hull, and that's correct engineering for a galaxy where blasters are standard issue. The armor defeats energy weapons because energy weapons are the expected threat. Endor handed the AT-ST a kinetic problem at the worst possible geometry, and the design had no answer for a threat profile it never modeled. The armor wasn't wrong. The threat model was too narrow. Active center of gravity management through continuous leg repositioning is the real fix. Boston Dynamics Spot continuously repositions its feet to maintain the center of gravity over the support polygon, catching itself through micro-corrections rather than relying on a fixed gyro with a finite compensation range. When the log hit the AT-ST, the gyro's compensation range was exceeded and there was no second response. A spot architecture AT-ST repositions its feet under the impact, transfers the load, and keeps walking. The Empire's AT-ST had one gyro, one range, and nowhere to go when Endor handed it a physics problem it wasn't designed to solve. The ATM-6, the First Order's guerrilla walker at the Battle of Crate in The Last Jedi, is the most honest engineering compromise in this list. Someone in the design chain understood the recoil problem and built a specific solution. Then they stopped before the solution was complete. EA/DICE, 2017. Crate. The Mega Caliber 6 cannon generates recoil forces that would drive a standard walker chassis backward off its feet. The ATM-6 addresses this by locking its forward legs before firing. The visual record of the Battle of Crate confirms it. The forward limbs brace against the surface, transferring firing forces to the ground rather than through the walker's own structure. Popular Mechanics noted this specifically in coverage of The Last Jedi, describing the ATM-6 as a vehicle that effectively becomes a stationary siege platform during each firing cycle. Their headline called it even less practical than the AT-AT it was supposed to improve on. The engineering failure is what the leg lock costs. A stationary walker at a known position, firing a weapon with a large, visible signature, is a predictable target for the entire fire window. Real self-propelled artillery move toward internal recoil management, mechanisms within the gun mount itself, hydraulic buffers and recuperators absorbing firing forces so the vehicle doesn't need to anchor to the ground at all. The ATM-6 needed a recoil compensator in the mount, not bracing legs. The legs solved the immediate physics problem and created a tactical vulnerability visible to anyone watching the vehicle operate once. The procurement team built a siege weapon, put legs on it, and called it a next-generation walker. The AT-ACT at Scarif is an AT-AT stretched to 32 meters and repurposed as a cargo transport. Taller means a longer neck lever arm, higher center of gravity, more mass over the same width leg footprint, and reduced armament relative to size because frontline combat wasn't the primary mission. Every AT-AT failure mode is present and geometrically amplified. Nothing in the revision from combat variant to cargo variant addressed the documented neck vulnerability. The ATDP from Star Wars Rebels is a bipedal walker armed with a single MAD 38 heavy laser cannon in an enclosed ball turret, crewed by one pilot and one gunner. The enclosed turret is a genuine improvement over the ATTE's exposed mass driver operator. That specific procurement mistake was finally corrected. The ATDP shares the AT-ST's support polygon problem by virtue of being bipedal, and it carries a documented electronics vulnerability. The command module is prone to failing under sustained pressure, and the T7 ion disruptor rifle disables the walker by targeting electronic systems in the head. An ion weapon that neutralizes a walker by targeting the head module is confirming, across a completely different weapon system, the same architectural vulnerability the AT-AT, AT-ST, and ATM-6 all share. The command cabin is the soft target. Every generation of Republic and Imperial Walker design repeated this mistake, whether or not they finally enclosed the gun. A note on the game footage throughout this video. Every title shown is labeled on screen. 5 separate comments on videos covering this subject asked what games appeared and never got an answer. That's a frustrating experience for no reason. Star Wars Battlefront 2 from EA and DICE in 2017, Star Wars Battlefront from 2015, Star Wars Jedi Survivor from Respawn in 2023, Republic Commando from LucasArts in 2005, and the Clone Wars animated series provide the visual record here. The games aren't canon to the mechanics arguments. Walker health values and firing arcs are gameplay abstractions, but the visual reference is accurate to the vehicles themselves. The Walker Dreamer position, that these machines are genuinely formidable, that the concept is sound, that walkers have terrain advantages wheeled and tracked systems can't replicate, is correct. DARPA funded the LS-3 program with Boston Dynamics specifically because legged vehicles traverse ground that conventional armor can't cross. Stepping over obstacles that stop tracks, distributing ground pressure through discrete contact points, maintaining stability on uneven terrain. The engineering case for walkers is real and documented. The AT-AT's 6-leg geometry was correctly designed for stability. The AT-AT's armor was formidable by every canonical standard. The AT-ST's 90 km/h top speed over flat terrain is a genuine tactical capability. The skeptical position, that legs are just a worse form of movement, holds only if the terrain is flat, the threat arrives as a tracked vehicle, and the opponent can always predict the approach vector. Real military terrain makes none of those assumptions, which is why legged robotics research still attracts serious defense funding. These walkers weren't inherently stupid. They were first-generation prototypes that were never iterated on. The comment sections on walker videos fill with the same instinct. Frustration at the obvious oversight. Amusement at the scale of the gap between the design's ambition and its execution. That response is the audience already doing this analysis intuitively. The tow cable geometry, the exposed gunner, the log trap. Those moments itch because the flaw is visible without a single calculation. This is just the vocabulary for what people already diagnosed. Real armored vehicle development improves because battlefield failure becomes the engineering brief. The Sherman tank's vulnerability to catastrophic fire from penetrating hits drove decades of redesign that eventually produced the Abrams separate ammunition compartment with blowout panels, armored fuel bulkheads, and automatic suppression systems. Documented failure, revised design, improved crew survivability. That's the cycle when it functions correctly. Every flaw in this analysis was visible before the first engagement in which it mattered. The AT's belly vulnerability was acknowledged by Lucasfilm's own databank. It directly prompted development of taller walkers. The 80's neck weakness was canonical documentation before any 80 walked onto a battlefield. The 80's bipedal instability was apparent from the height to footprint ratio and the single gyro dependency that the cross-sections book documented in 1998. The ATM-6's locked leg firing posture made it stationary in the first battle, where anyone could observe it operating. These weren't surprises discovered under fire. They were known. They were shipped anyway. Every fix exists. Armored fuel bulkheads, remote weapon stations, distributed control architecture, internal recoil management, active center of gravity management through continuous leg repositioning. All of it real, all of it available, none of it applied to the vehicles that needed it most. The walkers deserved better than the procurement teams that shipped them. The engineering was always fixable. It just needed someone who cared enough to fix it. Subscribe for more.